Now, last time my video abruptly stopped in the middle. Well, not exactly in the middle, but before I was finished. So I think I have to do from 102 onwards. Get this exercise finished. So let's have a look at that. So basically, we're just asked to differentiate and graph h and its derivative. So I'll just differentiate this, but I'll just maybe point out how we can quickly differentiate cubics, because a quadratic is a type of cubic with the coefficient as 0 on the square. So like if you just had some generic cubic, let's say fx equals ax cubed plus bx squared plus cx plus d, then fx plus h minus fx all over h. That would be ax plus h cubed plus b times x plus h squared plus c times x plus h plus d minus ax cubed minus bx squared minus cx minus d all over h. So when you cube that, the d's will cancel and all of these will cancel when these are expanded. So that'll be ax cubed, which is cancelled. Then that'll be ax squared with a 3 in it. 3ax squared h plus 3axh plus ah cubed plus bx squared plus 2bxh plus bh squared plus ch all over h. So the h goes, that's a square, the h goes, that goes, that goes, and then when h tends to 0, that's gone and that's gone. So this will tend towards 3ax squared plus 2bx plus c. Now I've done something wrong here because I was expecting that to go. That is I lost a h there, because that's x cubed plus 3x squared h plus 3x h squared. So there should have been a h here. I lost. That's gone. So I should have 3. Yeah, that's right. So it makes it quite easy to answer all of these derivatives then. So h derivative I can easily get, g derivative I can easily get, and f derivative I can easily get. And then what does the second derivative mean? These are the accelerations, because it's the rate of change of speed with respect to time, or velocity if you consider directions upwards, and their units would be meters per second squared. But let's just get these derivatives here. So that one would be 7.229, because in that case the a is 0, the b is 0, and the c is 7.229, and the d is minus 4.905. But it actually doesn't really matter about the d, because the d is not in any of the derivatives. Likewise here, again using the formula I arrived at, so that would be 2.858t plus 0.085 857. And then the last one is 0.6111 t squared plus 5.912 t minus 2.705. Okay. It's kind of difficult to answer which one fits it best with the software I have. I'm expecting it to be the cubic, but I'd actually have to calculate it to know for certain. But let's the graphs anyways. We have HT is 7.229 t minus 4.905. Then we have GT, it's not capitalized, okay, 1.429 t squared plus 0.0857 t minus 0.1429. And then F of t 0.2037 t cubed plus 2.956 t squared minus 2.705 t plus 0.4683. Okay, so let's plot. No, yeah. Just plot. Delete that. Okay. Just plot H, G, and F. Actually, maybe I should, so not to confuse the program, I'll just say y equals hx, y equals gx, y equals fx. Okay. Plot. 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 Okay. Oops. Okay, I don't remember what was the original data. It goes up to 5 seconds, so we want to maybe I can do set plot range. So let's go horizontal minimum to maximum, and the vertical, oh, what was it? How big is it? Only 32. Okay, so yeah, they're pretty close. They're pretty close. Now, I wonder if I still have the graph, I might be able to see which plot looks the best. Oh, I should also plot the derivatives as well. I can calculate the derivatives too. So if I just have H, G, F, huh? Oh yeah, of course it is a constant for the first one. Okay, there they are. The 7.229. Yep. 2.0. Yep. 0.6111. Yep. Okay, so they're all right. And I'll plot them in a moment. That's the height graph now. It's going to be a bit tricky to try and... Let me delete that one for the moment. Just try and... This one a bit larger. Yeah, that's too. Have to do a proper calculation. I don't know. They all look pretty poor, actually. I'd have to do a calculation to figure out which one is fitting it best. Yeah. There is a way in Excel, but I don't know if I can. Yeah, okay. Shell equation. All right, let's see. So the linear is a 92% fit. Okay. And then let's see the quadratic. Oh, I can show both on the same graph. Okay, I didn't know I could do that. The quadratic is 98% fit. So let's have a look here. And is it the same equation? Let's have a look. Oop. Cubic is 99% fit. Is it the same equation? No, it's not the same equation, actually. That's interesting. So my cubic I found and their cubic given doesn't match. So I think the cubic, as I originally thought, is the best fit. Let's see the quadratic. Does that match? 1.429. No, doesn't match either. Unless maybe I've done something wrong. I wonder, are these the best fit? So here, best linear fit, best linear fit, best linear fit. I'd wonder, are they really? Oh, and we also have to calculate the second derivative as well, which I nearly missed in question 105. So h dash dash t, that would be 0. G dash dash t, that would be 2.858, and then f dash dash t, that would be 0.6111 times 2 is 1.2222 t plus 5.912. Okay, so if I answered everything, no, I still have to plot the derivatives. Okay, very messy. I don't like these. It's a very poor question, this batch. Oh, and it does say on a separate one. That's good, anyways. So I should delete these and do it on a separate one. It makes more sense because the units are different. There we go. There we go. There we go. Right, graph H and its derivative. I've done that. Graph G and its derivative, which I've found. Graph F and its derivative. Cubic, maybe. Can't really tell without doing a calculation. Using the best second derivative, which I have here. And what are the mean and the acceleration? All right, terrible question. Let's get it finished. 103. Okay. Yeah, that's right. It's the G dash represents the acceleration. Yeah, that's right. But we'll never know what the answer is. Oh well. Oh well. It should be the cubic, but I'm confused about why my best fitting doesn't match theirs, unless they have more data points to fit to, possibly. So I don't know. I don't think I'll open a ticket with it. Don't be particularly keen on this question. All right. I think then that ends that question, that chat section. Great. Kind of a long one. I think we can probably get through the next one a bit quicker because it's differentiation by rule, which is going to be much quicker to get through. Looks like we got product, quotient, and chain rule perhaps in here. Anyways, yeah, okay, not too bad. That's for next time. Thanks for watching. Video didn't crash. We still have sound, so that's good. We'll leave it there. We'll leave it there for today, and I'll see you next time.